Let's start with our public method. So public list of string. We call it topological sort. We also need a private method, private void, with the same name. Here we need a node parameter. That is the node that we're visiting. We also need a set of visited nodes. So set of nodes, we call it visited. Let me put this on a new line so you can see clearly. That's better. And we also need a stack of nodes. Now, in our public method, we're going to call this private method. So topological sort. Now, what node should we pass here? Well, as I told you in the last video, we should do a depth-first traversal on every node in this graph. You want to make sure to visit every node in this graph, okay? So here we need a for loop. For node, in nodes.values, this is our nodes hash table. The keys are strings and the values are node objects. So for each node, we're going to call the topological sort method, pass the node object here. We also need a set and a stack. So let's create these objects over here, a stack of node and a set of node. We call it visited and set it to a new hash set. Now we pass this here. So visited and stack. Now once we're done here, our stack is populated with our nodes in the reverse order. So all we have to do is to pop all the items from the stack and put them in a list. So a list of string, we call it sorted and set it to a new array list. Now, while the stack is not empty, we're going to call sorted.add. Here we pop one item, so stack.pop. Here we have a stack of nodes. So when we pop, we get a node object. But here we want to return a list of strings. So we access the label field. And finally, we return the sorted list. This is our big picture. Now let's implement our private method. So that is super easy. In this method, first we want to make sure that we're not visiting the same node twice. So if the visited set contains the current node, return immediately. Otherwise, we want to mark this node as visited. So visited.add node. Next, we want to recursively visit all the children of this node. That is super easy. So for each neighbor or child, whatever you want to call it, in adjacency list.get node, we're going to call this method and pass this neighbor with the same set and the same stack. Once we have visited all the children of a given node, then we're ready to push that node onto our stack. So with this algorithm, we go really deep in our graph and find nodes that don't have any outgoing edges. In other words, there are no nodes that are dependent on these nodes. These are the nodes at the bottom of our hierarchy, like our project node. So we add these to our stack first, and when we pop our stack, these are going to be the last items in the sorted list, okay? So here we call stack.push and pass this node object. That's all you had to do. Now, let's test this. So in the main class, I've created the graph that we had in the last video. Now, let's call graph.topological sort. This will return a list. Now let's print this list on the terminal. So we get XBA